whatever it is, wherever you are. So last time, Mickens of Hero suggested a different algorithm that gave us something sort of good. I still want to try out the B-spline, see if we, first of all, just to see if we can figure it out. Well, maybe not first of all, but I'm definitely curious if we can figure it out. And see if that will give us a little bit better shaping control. I actually got to see kind of what, if the parameters are going to be easy enough to work with. Curve graph, maybe I should have a better way to, so we were playing with Visor, it should probably be a lead into other stuff. So I have to go U, change tab, reload. Oh, and that's right, we have to do, well, yeah, this is the part that's not easy to make conditional. Maybe I can figure out if there's a no-op actor I could stick in there instead. So that was our oversimplified Visor curve. Or just simple 0, 1, 1, 0. So we have that gives us our 0 to 1 number, and this is effectively influence. I'm not sure that method will work well. With this. Yeah, this is D of whatever. DJ is the... C was the factors. Wait, we just make that zeros and ones, and we got a curve we can multiply by anything. Now, parameters. So this is calculating. Right, everything up to P and then returning P. So a straight implementation of this would take exactly these parameters. Although I might want to rename them as much as it's nice to do that. So index of not interval that contains x. So this is for a particular position. Array of not positions, array of control points, degree of B-spline. So at this level, it needs to be padded as described above. jk minus p, jk minus p, j plus 1 k minus r, I'm going to have to do this straight and see if we can actually make sense of it. So knots and I'm not really sure what degree is. And then we're going to have a function of x, index of knot interval that contains x. So we have to do that. Equals 1 to n do. And do we have a definition for that? Well, I know there were some other sections. If x less than or equal to and less than. I guess it would break. If we broke, it would just be I. Then we need that. If not sub I, and then if we got to the end, we'd have to assume the end, I guess. Or assume something. So that gives us an index within there. Then we have this. Where D is just a traditional name for this. Plus K minus P. P is the degree. Can this get us anything at this point? We could that will get us the knot position. Which by the usual padding would put us there. Alright, so B-spline, and leaving out X and K, we have knot positions. I don't know what the limits on range are. So can we just go 0, 0, 1? That might resolve to kind of a Bezier curve style thing. Well, no, we'd need at least like 0.5 to do a center. And then we would have 0, 1, 0 for the levels, and maybe it needs to be 2, I'm not sure. Now this is going to be a super simplified, inaccurate version. Oh, your Lewis and. That should have returned something, right? Okay, we only ever detect a single index. Which probably means number of knots. It'll still be 1 per x. Print. Oh, no, report. I can verify what that value is. Five, yeah, that sounds about right. Unfortunately, now we have to spam, 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 because this is being very weird. Oh, how about nuts? So this actually has to be t plus 1 but that means this has to be knots minus 1. Oh, I'm not printing anything now. Well, we know that that's pretty much to 0.5. Oh, right, because we have 2 ranges right now, so we can really only select 2 indexes. In the... Hey, Pollux, how's it going? I think I remember your name. It's been a while. Alright, so that's a reasonable result from there. Now we want to actually get, no, levels. I think. No. And global I. Oh, no, right, it's index. It would match the code, but we're only reporting constant levels. So we think with the way the real algorithm works, we want that. And we're actually defining two curves over this section. Although, wait, does x ever even come into this? X minus divided by. So that's probably the progression factor from one point to the next. Alright, so we need an initial definition of, I don't know what else it's called besides D. Which is going to be a table. In range 0 to p plus 1. But these arrays are indexed by 0. So to index into levels, we actually have to do I to degree plus 2. And D sub I equals C sub I plus K, the index, minus the degree. So it's iterating over a couple of things. Okay, so I'm moving index back to the start position and then advancing through that number of steps. And the final answer of this would be that. So just syntax check, which failed. Question marks. Man, I don't know how long it's been. I've been doing a lot of 1R1 Life stuff. And hacking on that. I'll probably be hacking on that tomorrow morning. So I'm gonna play around with some of the server stuff and some interface stuff. Need to get back to making money. Need to finish up my tax stuff. I'll be doing... Oh, actually, that reminds me. I wanted to say I was doing that. Back with Subnautica. Uh, Okay, so that's taken care of. Yeah, so I'm trying to implement some math to figure out the gameplay curve, which won't show up right now because it's broken. 968. No, I minimized you. 966. Oh, right, it's not C. It is levels. I mean, C for constants, I guess, sort of works. Oh, so that kind of offset it by one, I think. I also don't know if I'm implementing the array extension correctly for this for this rather arbitrary number of degree. And I mean, degree 1 might actually just be this kind of thing. I just want to start super simple and then play with the parameters. Of course, since the algorithm requires you to extend the knots, I'm wondering if I could just have the code deal with that extension. Like if, well, because everything expects to do offsets to get the numbers, so. All right, and then 1 to p plus 1. Okay, so that's indexes of there. What does that mean for us? R is a... And then we have an R minus 1, so that does kind of have to be a 2. Which might change some of the offsets elsewhere. And then this is just an arbitrary iterator. And this is... So does this have to be degree plus 1 now? Degree plus 2 to... One to p plus 1. P from r minus 1. I think Lua does this. I may have to... I might be wrong about that. Alpha... So this is our x minus, and then our t was... Oh, so this is a problem. We're doing minus that. But our range of there is plus 1. Maybe it would be easier to do a plus 1 on all my indexes. That way we can keep all this math the same as our example code. Index minus degree divided by and then this is all of the numerator and all of the denominator. One plus 1 plus I plus 1 plus index minus R minus naught of 1 plus index plus, or plus this loop, plus the index of that. I think I know what's going on here. Wait. So that's this number. So conceptually, well, no, because that's minus R. So I sort of understand, this is local, that we sort of have the start point of the range we're looking at is naught of I plus index minus, and this is, yeah, T of naughts. So we have sort of the baseline we're differencing from. X minus start. And then the weird one is we have a very, very similar term, but it's like I plus 1, but it's minus R. One to P, number of elements we're considering. So it's always the amount that X is into that. But it's divided by this like moving window of how different right, and it's index plus 1 offset by the R factor, which is that. So that's the start of that degree. divided by could that be ever be divided by 0? J plus 1, k minus r, k minus p. P to r minus 1. Well, it starts at p and it's plus 1, so it should never be 0. So is that like... Right, as the difference gets larger, the influence should get smaller? But you would also think there would be smaller influence on the first point. This is like the start of this little section. Divided by the difference with all the forward points. Oh, but we're backing up. Forward point minus current point. How far different it is. So is that like an end? Then d sub I equals... I don't remember if flu is loosely float or not. Okay, so inverse of alpha times... And the minus 1... But we've defined the entire thing, and now we're kind of counting backwards. It's di plus... Right, because that one's going backwards. And then we're blending between this and negative alpha times minus 1 plus alpha. I know there's precedence there, but it's not too ambiguous in multiplication at times, but just as a general habit, I like to be more explicit. Oh, n doesn't work, does it? That may have been too much at once. Arithmetic on field 974. So knots is properly indexed. Oh, this is plus 1. Or actually, I guess the better way to do this is the 1 plus. To properly indicate what the heck is going on here. Oh, and it's not J. (974). I probably need to check out if that looping actually is doing what I think it's doing. I think this is 5.1-ish. Statements. For statement. Comma, comma, comma. Var limit step. RI. Actually, does it work like that? We know it doesn't happen until this. We can get everything up to here. I might have to explicitly stringify things. To call Lua dot. Yeah, do I have any other places where I report multiple factors? That's pretty much string concatenation. This is not super pretty, but I'm just interested in getting some basic information out right now. Okay, so first loop. 1, 1, degree 1, 1 to degree, so 1 to 2, from 1 to 0, minus 1, yeah, because we're going to do index plus 1. The first point we selected was 0.5. The second point we selected was 1. The calculated alpha was negative 0.998. Which might be reasonable. Well, I'm not so sure about the negative part. We've clearly picked actual values from the knots. Oh, wait, am I getting my... Is this supposed to be I, or... Index, J... Yeah, K is the selected index. This is the one we're iterating over. Plus I, so 2 equals... I'm going to have to pull this all out into separate variables to figure out which index is actually failing. Oh, actually, well, actually, it's sort of reporting all the individual values there, although a lot of them are temporary. Yeah, there's temporary, so we don't have proper names for them. Arithmetic on field. Uh, DI or previous works too. And we've got alpha. And those are the only values of interest here. Now hold this. Concatenate local DI and nil value. Oh, this needs to be a +1 too. I'm surprised you didn't complain about assigning to 0. But I guess they are just kind of tables. Still had errors though. Set the concatenate local dip and nil value. So 1 plus 1 minus 1 should have been something. So alpha. Oh, maybe this is in the second loop? Wait, what? How you... How? I know that it tries to block repeat entries of things. But we were... Oh, because that would have been repeated wherever we weren't doing that. So it still looked like this. Then we would... Wow. Negative 0.98 to 002? Right, so influencing the other way on the other point. But that should have changed my values? So we do 1, 1, 1, 0, 0.51, 0, 0.5, 0.2. 0.51. Attempt to concatenate dip a nil value. So I is going. Oh, I is 0. 1 plus 0. And the previous 1 plus 0 minus 1 is 0. So just offsetting this stuff by 1 doesn't do it. But the original setup, 1 to p plus 1, degree to r minus 1 by minus 1, did not calculate a negative 1. Maybe p has to be at least 2. And I was trying to start it off at the most basic level possible. But that might still have... Or maybe 1 already needs more padding? That looked like 1, 2, attempt to concatenate local dip a nil value. Nope. I didn't want to do that. I couldn't see what the heck was going on. So maybe with 2 we need to have some extra knots in here. Dip a nil value. Or was that reloaded from the proper thing? File is saved. We duplicated all of our number lines. 1, 1, 0.1, 1, 2 is 0, 1, 1, 1 is 1, 0. Which got us an alpha. And 1, 0 is a problem. I'm also not sure I'm doing the padding right on the knot. One plus, 1 plus. Oh, maybe my knot detection is index that's at. For this math to work out, maybe index has to be I minus 1? I saw an inf in there. Concatenate local dip a nil value. Because that's expecting that to merely be a zero-based offset. Oh, but that means that our default value also has to be this. In case we roll off the n, so that didn't error. But we also didn't change screens. Which means there was an error, it's just not showing up anywhere. Oh, are you kidding? What is it, like, no? Long bracket. Literal strings, not strings. Comment starts to double happen. The text immediately is not an opening long bracket. Wait. Oh, right, because we had the double function here. Oh, no, I only wanted to return from that one, really. Actually, really, yeah, this actually is fine. We just need to remove this stuff for now. Okay, we actually changed screens. So something in here is breaking and not causing an error. Which is extremely annoying because I can't debug not an error. Okay, well now we've got an actual error. (977). Maybe I didn't change the error message so it blocked it from repeating. One, two, 1, 1, 1, 0, inf. Well, inf isn't any good. Yeah, so we got 0, 0. Alright, I need the proper definition of how I have to pad this thing. Or maybe I have just over padded it in the process of trying to fix this. 4 degree 2. So now we got zeros where we don't need zeros. That's not even loading the first bit. Oh, because it's a syntax error. It's not telling us about a syntax error, but it's syntax error. And it doesn't look a very different error message. Yep, concatenate local dip. So it's not that we had too many zeros and had a no difference. It's that we once again iterated off the bloody end. All right, we need to have the padding rule down properly. Control points. I sort of understand what's going on here, and I really don't understand it how it's presented. And especially the algorithm starting out, I'm saying, okay, there's an influence level for each point, but okay, well, here's examples with knots. Quadratic and cubic doesn't tell me what our degree is. I can see, well, I guess quadratic is the simplest possible. That's with 5. Does it have to have that many control points? Or is it just the fact that that level of curve... Oh. So actually, so you have 8. So actually, it's not just extension. Those are actually like in-between points. So for 5 points, we have 8. Of there. Now their cubic example does get... Okay, so this is quadratic again, with a lot more detail. So this is like in between these points. Well, in between somewhere. Yeah, in between 1 and 2. 0, 0. 0, 0 extra. But I need to know what the number for that is to match it. Degree n minus 1. Spline of order n is n minus 1. Knots T0, 1, 2. Knots are distinct. Defined over 1 plus n locations, called knots. The degree n minus 1. Is it always plus 2? I thought it increased with the degree. Weight times that. Zero, 1, 2, 3. Order 3. What does order mean? Yeah, I thought I had found a thing like you have to extend it by... Internal knots to be extended with n minus 1 end points. 1 plus n knots. With n minus 1 end points. So that actually grows, the extension actually grows considerably as n increases. But that might, does that mean we do need lots of interior points? 1 plus n locations called knots or breakpoints. Internal knots cover the X domain. N plus 1 knots follows the external knots need to be extended with n minus 1 endpoints. So our example, well, you know what? The easier thing to do is going to, well, except I don't know what number to put in for the n. Well, no, because we can back work this from 3, 3. And 0, 0, 1, 0, 0. So that's number of control points. The actual knots are 0, 1, 2, 3, I think. Spline of order n, degree n minus 1 in a variable x. Extends over 1 plus n knots. So this would be of 3. Extended by n minus 1. But then our control points are like n plus 2. Yeah, so the annoying thing is here, they don't define what the n is for this. So we have to try and back it out. Nope. Cannot get to that. So yeah, and then the off by 1 and arrays is messing us up too. A fully worked example would be helpful too. With n equals p plus 1, b splines of order p plus 1 of degree p find over a grid of knots I equals k minus p to k. Unless the sum is reduced to I equals k minus p to k. Current index. The not interval that contains it, but we only do it over the previous points? Or it contains the interval? Not location is at index k plus 1 plus p. Oh, for PE, real not locations. Oh, so we have to extend by 3 beyond the real not locations. So that means that doesn't give us control point values for that. Although this is 0, 1, 2. What's the control points for that? Well, yeah, that's an odd number. Right, if it's in betweens, then that would just be an even number of things. A fully worked example would be helpful. Real not locations. That gives us real not locations and the extension for p equal 3. What's the control points for that? Zero, zero, 4 zeros. 1, 2, 2, 2. So extend it by 3. I'm going to guess it's 3 or 4. Or no, rather 2 or 4, because it's seems to be a different parity than the baseline. There's an inf, which means we got to a point here that we didn't like. We didn't have trouble indexing into this. Be new control points with 0 equals ci for the R, recursion. Types of polynomial functions. What is the does this define a degree? Quadratic equation is in x and y, so that would be a degree 2. So cubic is degree 3? So does that mean this is degree 2, actually? So 3 zeros, 1, 2, 3, 3, 3. Degree 2, 0, 0, 0. Nope. E. Nope, still error. We still got an inf. Oh, didn't that say that this was defining n equals p plus 1? So this is talking, well, but what is this referring to? A spline of a quadratic spline, order n, degree n minus 1, piecewise polynomial function of degree n minus 1. That's saying that order is n equals p plus 1. That would say that p was 1 in that case? It's plus 1? We know 3 didn't work. No. Yeah, the dip is a nil value. Yep. Is there someplace else that gives an actual example of these numbers? So this is a two-dimensional. T0, T1, T2, T3, T4. 1, 2, 3, 4, 5, 6 piece. So P6, and we go to T equals 10. Oh, and then there's T4, T5, T6. Generalization of Beiser curve. Okay. Non-decreasing sequence with Ti and 0, 1. Oh, right. For my purposes, I would actually have to modify this. Which would have... But that would still... We were only evaluating it over a certain range. Tm, Pn. The degree is m minus n minus 1. So degree... Oh, the difference between them... Right, because it had to be extended by blah, blah, blah. So this is a 3, 6, 8, and a 5. So that's 3 minus 1. So this was supposed to be a 2. And I think it's not displaying the repeated error message, but I ended up getting some different numbers because of what I did here. N0, Nj, J minus 1. Ah, okay, so it's 0, 1. That's why you can just do constants. It still does not give us a worked example. Well, it gave us a useful definition here. And we might even be able to use that to remove this parameter. Although we'd still have to do this padding. Because in theory, this padding could be mechanical. So the straight up non-optimized calculation is t times minus 1, I plus 1 minus 1. Yeah, time... Right, so that's where the recursion is recursive. T minus ti minus t. What's just t, though? Without an index. Is that the entire curve? N greater than or equal to k minus 1. T is included in k minus 1 to n plus 1. T0, 0, 1 to k minus 1, k, n plus 1 to n plus k plus 1 elements. The number of control points n plus 1 plus the order of the curve. Okay, yeah, that... Right, and then this is kind of what I was thinking about. These are all like the influence vectors on different points, which is kind of what I thought was going on. Covers the interval, is helpful in improving numerical accuracy. Order 4 B-spline basis functions with uniform knot vector. A clamped cubic B-spline. So this is two-dimensional control points. Hello. Seven, 8, 9, 10. Six, 5, 4. K equal knots, K equals knot. And minus K, right, K, and minus K plus 1. Well, we sort of have some things. N plus K plus 1 equals 2K, or N equals K minus 1. B-spline to Beiser, okay. Order K with no internal knots and the endpoints repeated. Algorithms for B-splines. Using the de Boer algorithm, okay, which you're already looking at. I am trying to do Lua to get some defined curves in Stepmania. I can't actually get to the screen where we do curves right now without, well, I could put in a previous one. So I've got a bunch of overcomplicated stuff. I'm kind of trying to play around with what I can do defining curves. This is a Bezier which has limited size, and in one-dimensional form doesn't easily meet my needs. So I'm trying to extend that to B-spline, so I can kind of define warm up, main, and cool down a little bit better. Somebody did suggest a basic exponential formula, which is pretty good, but I kind of wanted to play with maybe offsetting it a little bit and things. But I have just, I think it probably has something to do with the fact that Lua is 1-based and the algorithm we're being given is 0-based, that is just throwing everything into chaos. So I'm trying to find like a complete worked example that we can just plug in and say, okay, we know all these numbers make sense together. But yeah, this is all the math stuff. I want actual numbers. At values 1, 2, 3, 4. That's a little bit too worked. I clicked directly through that, didn't I? Computation examples. Not vector. They're using different terminology. Oh, you're degree 0. Okay, so degree 0 is supposed to be a thing. I mean, it's just straight up hard linear. Hence, the basis functions maybe I don't even need control points because I just want to go 0, 1. Well, no, I need an influence map times some constant. So that's the influence function. Degree 2. This must be degree 1. So these are only the basis functions. It doesn't tell us how many control points we need. Well, no. Right, from those 4 points, we've gone from 4 to 3 to 2. Well, there might be some other endpoint functions here. Maybe he's erased those. 0, 2, 1, 2. These are basis functions, so at degree 0, if we do 0, 0.25, 0.75, oh no, 0.5. So this is actually 5 points for basis functions. 0.751, which means we would need 4 points. For my purposes, it might look something like that. That's 5 points. Which is looking a lot like the Beiser curve. They said this is that minus that plus 1. And we're still getting an error indexing off the end. Repeating some of... I would have expected different numbers to show up there. Maybe the interpolations are still there? Okay, so the degree is 0. We go from 0 to 1. Wait. That doesn't give me my number of levels. Maybe this algorithm is for very specific relationships between things? Degree of B-spline. They might be assuming a certain number of points for a certain degree spline. What we really want to do is define this for every p plus 1. That is getting control points. That is the only reference to the control points. Oh no, this many... The D that we're interested in is the things that can affect us. So that's 2 things that can affect us. We picked the index, which the index is one we have not been printing out. For x, this is getting really messy. Selecting index, and then all of our iterators. So this is sub-selecting from levels based on that. So yeah, our two immediate edges, essentially. Oh, wait, you're actually going to do, wait. Zero to degree plus one. So that's just going to get, at degree zero, no, wait, it is degree zero, so that will get two things. And go from 1 to degree plus 1. So that will only evaluate once, which is fine, because this is a linear, straight up linear thing. Then we go at 1 to r minus 1, from 1 to 0. That should be that. Calculator or not, we cannot... Oh, my problem is usually 1 plus 0 minus 1 is 0. But if this is 0 minus 1, that's already a problem. I might... want to go ahead and make these J's just so I have an easier time following this algorithm. I tried to rename things in a couple of places. So get down here, we have J minus 1 and J. J is going to be... So our court, well, that will actually spam the heck out of things. Because that's going to change in every line. Well, you know, until something breaks. So concatenate local value. So every line we printed was duplicated? Or we didn't save. Something about this debug output automatically removes duplicated lines. So at x0001, we picked index 0 of the knots array. No, it will pass this, but it should not pass this. And with at degree 0, or actually at this example, there are no 0, 0 things. So the first index is correct. Then we go to r equals 1, because it's 1 to 1. We go from 1 to 0. And this is actually taking long enough. I probably need to label these. Index 0, r0, j equals 0? Oh no, that's straight up degree. You're not degree plus 1, are you? No, you're degree. 0 to 0, right? It's only a singular thing. And then... Is 0, 0 right? In knots? Probably not. So that is 0 to 0. So 1 plus 0 plus 0 minus 0 is 1. We are going... This might be degenerate because it's degree 0. Plus 0 plus 1 plus 0 minus 1. So that actually is degenerate in this algorithm, at least. And that at degree 0, it's just a straight up 0-1 influence. I mean, we could skip this loop at degree 0, which doesn't necessarily help me debug it. What is 1 to degree plus 1? So that's 1 to 1. That's 0 to 0. I guess we just say degree greater than 0? Because I don't know how to make that math work. If we're always selecting the same point, actually, how does that work? We have 5 vectors. The influence vectors are D, select that. So there's no actually offing across. So, I mean, that trivially does not do the dangerous calculations. Also does not actually return results. And apparently doesn't print anything. Oh, right, because all the prints were in here. So this needs to actually move up to this, I guess. Because index should be changing. J... I guess from to... Yeah, that's the words I was looking for. But then we have to use that. None of which will actually be going right now. Okay, so that was predictably spammable. But I didn't see enough of them. So let's try a more manageable number. Now, it might not be able to... Okay. That's still not drawing points, though. So 0, 1, 2, 3, 4. So we do sort of have a problem with the, with the end. And that there is no index for... There is an index for... No, we should have 0, 1, 2, 3, 0, 1, 2, 3 if it's 5. If it's 5. So at 1, less than or equal to that, and less than knots, there is no knots plus 1. This is my failover case. That's it picking it. Wait. Break is not working. No, that's the level it got to. It didn't repeat the previous ones. So yeah, when we do 1, it selects nothing. It goes, oh. Index is the one we select minus 1. But we're still not getting... Index 3. We're still not getting... Now, we have far fewer points. We should still see some points, though. What the hooey-hoo? That's a 0 to 0. Somewhere here I dump tables. I don't know if that works with arrays. One, 2, 1, 0. Okay. 0, 1, 1, 1, 1, 0, and only 0. How? Why is that table a different size? Oh, if this ends up going off the end, then we couldn't actually assign anything there. So that's from 0 to 1, which ends up being 1, 2. 0, 1, 1, 1, 1, 0. But whenever we select index 3, we go, I presume that's 1 plus 1 plus 3 minus 0 is 5, which doesn't exist in our lesser table, or other table. So do I need, I shouldn't need 5 control points, there's only 4 functions here. Zero to degree plus 1. Index plus the interval that contains it minus the degree. So I've cut out the index 4 that actually hits the end. Wait, shouldn't this have... Yeah, minus degree is supposed to be the offset for how many padded things there are. There are no... It's degree 0, so it's not padded by anything. So knots should be 1 longer. Zero, 1, 1, 1. 1, 0. What were the things I put in here? So we're doing 10 of these. I might actually be evaluating this at 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, index 2, 2, 2, 3, 3, 3. Yeah, so this is 0, 1, 1, 1, 1, 0. Right now we are using an even distribution, so 0, 1, 1, 1, 1, 0. I wouldn't expect 1, 0 to be kicking in at the halfway point. One, 0 should be kicking in around here. So in our first pass, and really these should be in the other order because this is where we select, or we get X and select index. So our first pass goes there. Duplication prevents us from doing that on every single pass. The first interval would, I expect, be index 0. So in a multi-degree situation, that would be... Oh, wait. Yeah, you're degree 0, so this also has to be plus 1. That fixes what we Okay, so that would be why we're not seeing anything. I think. Okay, 0, 0, 1, 1, 1, 1. Right, so we're always picking 1. So 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0. So that kind of works. So now the messy bit. Anyway, I wonder if that degree thing is what was messing me up. To do a degree 2, actually part of that might just be we have fewer of these because it ends up being the difference of those. So that only gives us 3 functions, so we should only need 3 data points. Nope. Wait, 3, 4. Oh no, I want to go to degree 1, not degree 2. So that goes to 3. So we're not even putting a degree, 1 plus degree into the table. So we're going to end up pulling 2 when we're done. Which feels... Isn't it supposed to be calculating from degree minus that? Well, those are the data points we're interested in. And now we should actually be blending between them. And we can't pull our previous value. Alright, so this was going to repeat 0.1 index 0. We created a table that pulls out what? So this selected an illegal value. That's why we can't get previous. It was a null, it didn't assign it and put it in the table. So this is 0 to 2. At 0 equals index 1, we tried to pull 0 plus 0 minus 1, 0. So this table the interval knots. Oh. Maybe this is where we do have to... Those are the interval knots. They're not describing the knot vector here. So maybe we have to do that and that. But then the equivalence of this says that we have to have a 0 here and a 0 here because we should have extra stuff. Although I wonder if I don't actually want to extend the 1 in there. But there's still only 3 functions. Nope. So that gives us a 1, 2, 3. And that gave us an index 1. But we selected a 0, 0 and had no difference when we got to division. And previous is still a nil value. Yeah, from 0 to 0. Although despite the inf, we actually crashed on, so again, not being able to find our previous value. Well, J0. 1 minus 1 is 0 again. Wait, how do we have... Oh, 2r minus 1. R is 1, so r will at some point be 0. But we've done the plus 1 to offset that 0. Does this have to be 2 and 1? Well, I mean, 2 would be the same as that. Does this have to be plus 2 and... No, because that's not actually a minus 1. And this is suggesting... Well, no. 1, 2, 3... 1, 2, and that's the same as this. 1, 2, 3, 4, 5. Okay, so I guess that is 5 over 3 functions. Continuous at knots. So we got it to do 1, and this should be, oh, this is degree 1, so that's going to select 2. So the one in the middle, and it has reference to these others, I guess. That's ultimately going to select, but... What the heck are we doing here that we're getting inf? Well, there's 2 problems. The actual crash error is that this doesn't exist. Now that used to be 0 based, and they were saying j minus 1. One to 2. One or 2. Well, no, this is 1. 2, that is going to be 1 or 0. So it's going to calculate this twice to get the 2 zones in between the 3 levels we picked out. And we would need 3 points to calculate stuff in here with 2 ramps. So our pass number is 1 or 2. And our first pass, that's a 1. Well, 1 to 1, and then 1 to 0. So j equals 1. That is fine. But when this goes to 0, is this only valid for degree 2? No, because this is always going to start at 1 and go to r minus 1, which is 0. And then we do j minus 1. How does that work? It doesn't work. Is that supposed to be j plus 1? The next point rather than the previous point? That's the alpha. That says j minus 1 too. Oh, this has a specific definition for j equals 0, but shouldn't that show up here? So this is sort of setting up j equals 0. Which is what this is sort of supposed to be setting up. The first pass. But that's nowhere in this. It is pass-wise for j equals 0, iterate r for 1 to p. Yeah, so that's the first pass? Now, iterate r equals 1 to p. D sub j, alpha sub j, d sub j minus 1. It's not iterate. Oh, j equals p to r. P to r. Iterate for r equals 1 to p. Wait. Why does that say r minus 1? This says j equals p to r. Which would kind of solve this problem too. Well, maybe, because you do 1. Well, it'd be 1 to 1, and then... Well, no, yeah, 0 to 1 by minus 1 would, in theory, solve that case as well. And we would not try to look up 0 minus 1. Why is that there? Error running function. Attempt to concatenate local DI. We got a little bit farther in. So now, yeah, x1, index 5. So now we're kind of at the other end. And we have a nan. Wait, from 1 to 1, right, which is 0. X is 1. Our numbers... Right, 1, 2, 3, 1, 2, 3, 1, 2. This... Wait, this is already over-indexed. We just never even got here before. So from 0 to 2, we get 0, 1, 0, 1, 0, 0. I feel like my index detection might be off, because the way things are set up now, shouldn't we have a 0, 0, 1 starting out? Well, that may have been repeat blocked from here. Yeah, because we got no table on the first pass. We didn't get this either. Yeah, all that first pass stuff. So 0.1 index 1, 0.2 index 1, 0.3 index 2 went 0, 1, 0. 0.4 index 2, 0.5 is already going to 1, 0, 0. I don't know, it feels like the 0.5 should really be more like the 0, 1, 0. Do I need more not padding? Well, there's supposed to be a relationship between knots and levels and degrees. If I add more padding for degree 1, I also have to offset that. Which one was it had that? Degree equals m minus n minus 1. So if we have 5 points, no, 7 points minus 5 points minus 1, that's degree 1. We can't just arbitrarily add extra knots without changing the degree. Although that means that you could make it degree 2 by only adding 1 knot? That doesn't seem quite right, but okay. So we failed to look up a level but the number of levels or control points is defined by m and n relative to degree. But I feel like this is kind of picking the wrong point. It's almost like it should be 0. Like it should be prefix loaded instead of equally balanced as the other examples suggested. So this must be repeating the last error exactly. Except we're not sure which of these things might be not repeating. So that's where that thing gets really frustrating. I essentially have this random number in here just to say, yes, this is the point where we reloaded, because it has this duplication blocking. A nil value. The problem here is now I don't know, like, I don't know if this nan... Well, nan must have repeated. Wait, we should have just changed the relationship. Oh. Does it actually need to go the other way? So it doesn't go off the end? No, because now we got a 2, 3. We can't get dip. But these are supposed to be related to each other. So that got different indexes. So now we can't get the current because our index has moved up too much. All right, so given we're trying to enforce a mathematical relationship here, so we expect you to be 3 minus 3 minus 1. Five minus 3 minus 1 is 1. Okay, so some of the indexes are the same. R1, J1 from 0 to 0.5, calculating 0.2, 0.4, 0 to 0.5, 0.6, 0.8 ratio. Then we get a table of 2 elements. 1, 2, and we should have a third. 1, 0. Oh, 0.5 to 1, 0, 2, 4, 6, 8. But when we do x1 index 3, and that is 0, 1, 2, 3, 0, 1, 2, maybe we just need to bounds check index? But if we get index 3, what the heck could have gone wrong here? All right, that's a valid not. Oh. There has to be something with degree here. But we're already 1, we're testing degree 1. So our default index is the last index minus degree, but we actually had this problem with degree 0. Maybe it should actually be just levels minus 1? Because that's ultimately what the problem is we're trying to index into levels. Although it's supposed to be the not index. Maybe I'm misinterpreting that. Index of not interval. It's described as a not interval, which I would think would mean it was in the not array. Or the control point, or the not array, which is extended. And we're subtracting degree from those indexes at various points to convert it into a level thing. Yeah, so actually you should be... That should be fine at knots, because whenever we do index stuff, that's from knots, that's from knots. Whenever we look up levels, we are subtracting degree, which should be offsetting it by the amount it's offset. But if we select 3 in 0 base, that gets us off the edge. So if this fails, it should just be... Oh, right. Well, I mean, it should be the last valid index, but that should be minus degree, which puts us back to minus 1, which wasn't working. So if there are... We're currently doing 5. Yeah, 0, 0.51 with 1 degree padding. 5 minus 1 is 4. The last entry. Oh, this is knots minus 1. I do need the minus degree. This is the -1 for the indexing system. I have to go back the degree to get to a valid range index because the stuff off the end is all the same and isn't a valid. There isn't a valid range. So it still seems like that r -1 might be a problem. Maybe it's not now. Nope, it's still a problem. That lets you go to 0, and then you do index 0 -1. All right. Well, I guess I should do the next degree while I've still got all the debugging hooked up. So if we take this same curve, we try to do it degree 2. That's only going to be essentially one curve with what we've got set up here, I think. So we need padding of 2. Oh. But that's not quite right, because they say they interpreted that as padding on either side. But the definition is we've added 2 to this. We've not changed this. Does that mean you have to do asymmetric padding? No. Unless it's asymmetric this way. No. Well, if we can back calculate the degree, what was... well, 1, 2. This would be like 0, 0, 0, 2 values, and we have 5 things. 8 minus 5 is 3, minus 1 is 2. So that makes it a degree 2 in theory. So 0, 0, 0, 0.33, 0.66, 1, 1, 1 to normalize it. But then this needs to be a vector of 5. So it's 8 minus 5. So if that was 4 things, you need more points than that, and we need padding of degree? But it was defined in terms of ratio of number of knots to number of control points. Maybe they're assuming a relationship between knots and control points that wasn't explicitly stated. This is not vector be defined, t equals m. Define control points, p to n. No limits defined, just p equals m minus n minus 1. Non-periodic, first, last equal to 1, p plus 1, and last p plus 1, which is the endpoint plus the padding of p. There's no real definition. I guess it's sort of implied. No. You're also having trouble. Oh, 0.1 index 1. We get 0, 1, 0? Already? Maybe it didn't print the 0, 0, 0 stuff. From 0 to 1, 0.1. From 0 to 0.5, we don't have an 0.5. I must have not saved. Oh. Okay, so one thing I'm curious about, before we take all this out. So got you. What was our degree 0? Well, in theory, degree 0 needs no padding. But now we have to hold a constant relationship between these things. Which means there's a difference of 1. So 4 points. Yeah, we're back down to... That's degree 1. Okay, I originally got this working with something else. Yeah, that was with a slightly different number. The thing I'm curious about is now that we do not have that r minus 1, can I get by without this? That implicitly does not bother to loop. Just does that constant. All right. So get rid of all the spammy spam, spam, spam. All right, so that's a constant function. I did not keep an example of a degree 1 around. Okay, so that's that curve. Now we can actually, now that we have something that works, and I'm just going to draw two curves at once. Oh, I started adjusting this and then I didn't. Does this make sense? All right, I was trying to get those numbers to line up. Well, this is degree 2. So we've really only got two breakpoints. And then whatever we've got in between there. Then what are you? It's right in the middle, all right. Oh, that's the range between 3 and a 0.6. Those are our two limits. So where are you? Okay, so that's the end. I feel like it sort of moved over. So that gives us 5 points. Right, because the knots are not the locations of the points, they're the places in between points. So we've got one here, one here. Seems like it would be a 0, 0. Right, because if we've got the middle. Well, okay, so it's still a little weird thing where it's calculating some influence over these. Okay, I mean, it still feels weird how we only have the two. It's only defining. It feels like this should only define 1, 2, 3 regions, but we've got 5 control points. And changing this would change. So moving this out to should I think? Yeah, move that out. Oops. So what if we made you like... Could we... Does this do anything? Oh. Yeah, that has to be repeated, or we end up selecting a range that doesn't exist. So we have to extend it, but we do have to have the actual full range defined in our basis points. But then it's so weird that we get to use the full 5 points when we only have 3 ranges defined. Oh, right. Helps if you save. These are control points. So that is affecting the angle of the curve as that exits. It's exiting towards, 1, 0, 1. We don't actually reach. It's pointing towards 0, pointing towards 1. We're not necessarily hitting those points. That might be a difficult system to work with. So the control points are pointing towards 0 to pointing towards 1. So pointing towards 0 off here somewhere, to pointing towards 1 somewhere in the middle. And I don't know. Yeah, it can point towards. Yeah, that does actually increase it a bit. You might be able to point towards a off line point, but you have to be careful that you don't actually nudge it over the range you want. And I'm using a very tight range right now, so I think this would be about equivalent to a smoothed version of the manual curve I was using. Could also try some smoothing at the ends. Well, it gives a nice curve in here. Or that gives some shape to the interior. To move the center, can't really move the center with an even system. And I would have to make this an odd system, which if I add 1 to each, that would so in theory, that's all defining intervals. Oh, because that's still two tangential things. Oh, that gives. So that lets us kind of push that back. And I guess that gives you a degree of shape control. You get relatively rapid rise up. And we could fudge this to change shape a little bit. I mean, it might be nice if you could smooth that out a little bit. And let's see, so what's really weird about this is that if you change degree, that changes all that by 2. So we have to remove the padding, but this also changes. Yeah, so don't get back down to 0. So it's basically not reading that other point. It's like the mode ping-pongs a little bit. Oh yeah, because that's actually hitting one. That is kind of weird. So that's a very, very complicated version of my manual flow. So that gives me a setting for warp and cooldown time, a settable centroid, which maybe we just offset it a little bit. Let's just go up to a certain level. We have the option to do that. Unfortunately, the way we're doing this right now, well, I should probably define these locally because we're just adding them. Because then I can do add the curves, base, range. And, oh, wait. No, no, we define the curves, and then we still have to eval them. Because that was all built using arrays, which we need to undo that, so I can have direct curves that I can eval at different values, or maybe store the curves, because... Alright, so now I can define both of those. Scaled, it was exponential, so it actually ended up looking pretty good. I didn't have an easy way to draw this, but did I copy that? We do have to, oh, we do have to scale it though. The scaling I don't think is going to change too much. Well, this is more like... shape equals, and then base equals scaled shape. So those are curves. We evaluated this structure, which maybe we want to make this structure do something else. However, I would still have to... I'm going to have to pull all this out. And add it together to graph it at high frequency, because it's not... So in theory, well, we're using that, but we're still using all the limits from the other stuff. So we've got lower bound, upper bound. So in theory, scaled arc factor 3. Oh, so that lets us reuse this. Scaled to different things. I think that broke something. That broke something rather badly. Who was it? Oh, I do have this sort of double multiplication effect with certain things. Or that the fact that I'm kind of using curves twice. It means the influence gets multiplied. Okay, so notes per second upper bound is just getting absolutely crushed by that. And that's just like a hard limit. Because this doesn't feel like the shape of this curve at all to just boom. I really feel like I need to undo a bunch of this stuff. Well, add curve base range. So our baseline, does this actually make sense? Does this make any sense at all? Oh. Oh, this was some random register value. I was not actually copying this. That'll do it to you. I thought I had copied this in preparation for moving on, and I was wrong. Expected symbol. Okay, that's scaled to a score range. I could this could be pre-scaled. It actually has... But I was dealing with some other mathematical formulas that could not be so easily pre-scaled. So it makes it a little bit easier to work with the shapes. Also, wait. Oh no, wiggle isn't actually the wiggle. Or it's the unwiggled, maybe? No, I actually cut that out when I was changing things. Eval curve, add curve. Wiggle base. Constant factor. Oh, exponential factor. Wiggle factor. That's... So we lost an add in there. Okay, so that's your shape. That is... Oh, this is the range for display. This terminal. So this has to be... so wiggle base is just... Maybe these aren't at all comparable. Scaled exponential factor, scaled exponential factor. Okay, so that's the same. But that is a constant factor versus a scaled wiggle. So you are the constant factor percent wiggle. But this and like wiggle factor is just the 0, 1. And I'm using scaled in a weird way. I probably shouldn't. So that makes this work. We just don't have this. Is that really getting that close to 0? Oh, it might be. And then getting cut off by my speed floor. It's like, is this making an appreciable difference? Yeah, it's making an appreciable difference. Feels like that's a lot more than... Also, I'm starting to see that hard binary effect. Maybe I still have something left in there that's giving us that hard binary effect. Oh, wait, have I even updated shape equals? No, I have not. And we got a very gradual wiggle this time. Maybe not the best example for fudging with that. Oh, yes, we got another very, very low one, which gets caught by our speed limit. Yeah, so the range is making an appreciable difference. It's mostly making a difference on the bottom. Which makes me think I'm not properly understanding something here. Well, I am using this in a little bit of a weird way right now. Oh, I might be drawing the range incorrectly. That might be what it is. That still feels like maybe more wiggle than we want. Although, right now, I'm setting a bunch of 9s and 8s. I think this was like 30. So it feels too big. Well, what am I even doing with that curve now? I need to reevaluate that. And I also want to evaluate how much work gets done every time we have to change the settings. It's kind of painful right now. Oh, actually it is kind of working the way I've set it up to the wiggle indents from the top. So maybe that's right. Well, indents in the top and bottom, but our bottom is getting cut off by other things. So 4, 4, 5. Eight, 7, 4, 8, 8, 6, 7, 9, 5, 5, 7, 6, 2. So cool off is okay. Warm up might not be too bad. And there's still a lot of things I want to rethink to see if I can simplify how we select this, although making any kind of user interface to customize these things would probably be painful. It's a very, very manually curated thing. And a very, very awkward thing to boot. I'm not entirely sure what happened when we went from degree 2 to degree 1. But at some conceptual level, oh no. Well, okay, as long as we offset by spaces, we're okay. At some conceptual level, some of these things are 2 digits, some of them aren't. So we've got our, well, our endpoints. And then we have some of these out to 2 digits, which So evenly space that. I mean, these are total fluff. That is sort of a required endpoint. Then it's like the 1, 1. Oh, and these could be O points. I guess make it 1.0 to make that take up the same space. And you're in between there. And I guess the zeros are outlying points. Okay, so the 1s are in between here, which is offset. Got 0.8 and 0.2. The right, so we softened that a little bit to get the curve up top. And then I guess these zeros are sort of in between there. This is kind of why I hate doing ASCII art stuff. It's very awkward. I guess these could be full-on values to make them line up better. But then we need to do, because you're the space in between there. Wait, is that right? So kind of doing commas to decimals. Wait, so what are you then? I just think I've lost. We've lost badly. And then to get this one, and you don't have decimal points. And that sort of describes what's going on. I almost want to say that this should be like alternating numbers, and we just space it out as from here. Well, no, it's not quite alternating numbers. Like that, at this point, do this level. So this might ultimately not be good just because it's hard to understand. But it did give in somewhat interesting results. We can try it out today. Now this one will not hit the peak as often as the previous curve, so I might be able to bump stuff back up. Although we do have a 61 there that seems to be hitting a peak point just fine. And curve graph. Oh, no, I've got even more stuff. Okay, so you are standard mode with a very, very highly tuned model. Oh, and now we got a new random pattern that's selected out of the 61. Yeah, I might want to tune the upper end back up. Oh, my settings. Did we end up using that? Or was I able to, yeah, bump flow. It's not such a simple thing anymore. Oh, that's what I was doing. I was, now that we fixed that, because we had put the wrong curve in there. This is a very long flow or long cycle curve. But I might have to, since this is a rather complicated thing, I think I'm supposed to use shape. Oh, we have to, nope, and beginning of the line, please. Realign that. Now, is that at a place where this can use it? Nope, it is not. $12.60, 10. Pardon? $12.60 should be below that. Oh no, because it has to be shape of stage divided by stages. We were evaluating it at that exact point. No, we are not. State. Okay, and that's bumping the beginning, which isn't necessarily what we want to bump right now. Ooh, that's actually going to peak up towards the beginning. Because we've got a long cycle curve. Alright, so I probably need to pull this out into a better definition. And maybe I store all of the formulas in our flow in addition to the evaluated ones? I don't know what you did. Oh, I've completely broken this window. Don't know what I did there. Um... Working, B-spline, factors, kind of hard to work with. Alright, so we can try dancing to it. It's going to be a little bit of a weird, slow cycle one today that might mask some of that effect. I guess you can see it a little bit in our speed limit. And I think some of the ways I'm using things might still be having sort of a doubling effect of some of the reductions. But that is it for the programming stream. If you're here for programming, thanks for hanging out. If you'd like to continue hanging out with me, oops, oh, I thought I got you. Sometimes the OBS just doesn't click. Anyway. But I will be back to play Sepmania. It's a good idea to actually get up and move every once in a while. Thanks for watching as well as hosting. Well, bunch of people today, mostly familiar names. Did I miss? Wonder if the alerts aren't working. Anyway, thanks for the follow. Schedule. So I'm usually working on code in the mornings, like Monday, Wednesday, Friday during the winter. I will switch over to Stepmania, sometimes earlier than this. It's going to make for a late lunch, but oh well. So I will be back in a little bit to play maybe this setup if I don't mess it up and bump something. If you want to hang out and watch me bounce around in a dance pad, please do. Otherwise, have a good day, and bye for now.